Welcome to your CCPS Science Review Lab. For today's challenge, I want you to go ahead and start by looking at these two models. And I want you to see what sort of comparison you can make between them. Again, I'm going to ask you to look for similarities between this model and this model. Great job. Now, to start off, here we have a model of our solar system, right? We can see the sun in the middle, and then we've got the planets, and these planets are orbiting around the sun, correct? Over here, we have a model of an atom. In the center, we've got the nucleus, and then we've got these electrons orbiting around the nucleus. So there we've already sort of named a couple of the comparison similarities that we can see. And then in both models, we have the object with the greatest mass in the center, right? If we think about our solar system, obviously the sun has far more mass than any of these other planets. And if we look over here at the atom, the nucleus, which is made up of both the neutrons and the protons, has way more mass than these electrons. Now, another comparison that we can make in looking for similarities is that when we are looking at how the planets move around the sun, we are seeing that the planets follow orbits, right? They're following, going around the sun. And in that same way, these electrons move around the nucleus of an atom. So those are our comparisons. Today, we're going to focus in specifically on these electrons and what we need to know about them, okay? So let's go ahead and take a look at another model. Here, I have a model of an atom. I can see here I have my nucleus. In my nucleus, again, I'm going to find my protons, positively charged, and neutrons, neutrally charged. And then I've got these shells going around, and we call those the electron shells or orbits. Now, each shell has a certain number of, they've got like a rule. They've got a certain number of electrons that they can carry. And the shells will be filled from the inside out based on those rules. Okay, so say for example that we had an atom with a nucleus and two shells, and it had 10 electrons. The rule for the first shell is that it can hold 2 electrons, so that would be filled. The next shell can hold up to 8 electrons, so then the next 8 electrons would set on that shell, and they would be zipping around on their shells. Now, we call the outside shell, so the last shell to have any electrons on it, we call those the valence electrons, okay? So they're the electrons on the outermost shell. Those are the valence electrons. And it's the number of electrons there and not there that determine the atom's reactiveness, okay? So the number of electrons on that last shell determine how easily or difficult this atom will pair up with other atoms. So let's take a step back and kind of review again. That was a lot of information. We know that electrons are negatively charged subatomic particles, okay, that they hang out outside the nucleus and they move along these orbits surrounding the nucleus. Now, the last idea I want to touch on, lots of times we get confused when we're determining the mass of an atom. Why at this stage of our scientific inquiry are we only looking at the mass of the neutrons and the protons? Why don't the electrons get measured into the mix? They're obviously there, so why aren't we counting them? And the way that I explain it is, I want you to imagine for a moment that you were to step on a scale to figure out your own mass. You were to look down at that number, and then I want you to imagine plucking out one piece of hair, pop right off the top of your head. would removing that hair change your mass in any way that would significantly show up on that scale? It wouldn't, right? Because that hair is so teeny, teeny, tiny relative to the rest of your mass. It's not going to make a significant difference. Well, that's kind of how electrons are. They're so teeny, teeny, tiny compared to the rest of the mass of an atom that we don't need to count them at this stage of our scientific inquiry in the atomic mass. So that's what we need to know about electrons. Here's what I'm going to have you do. It's your opportunity to show what you know. I want you to look at these 3 examples, 1, 2, 3. You're going to find the number of electrons in each example, the number of valence electrons, and then I want you to count the number of electron shells. Good luck!